Hi everyone, this is Mr. Lee. In this video, we are going to go over potential energy. So this is the first of the 3 video series where we discuss potential energy. So let's start off with the definition. Potential energy is the energy that is stored in an object or a field, and it is position dependent. So let's go over the idea of what I mean by energy that is stored in a field, because that's what we're going to be looking at here. So here on Earth, right? If you have an object that is above the floor of the Earth, or like where its height 0, we know that when we release the object will fall. Pew! Right? And we say the reason why it falls is that there's a force of gravity that pulls it. Now, another way of viewing this is that the reason why the object falls is because we exist within the Earth's gravitational field, meaning that we all experience this gravitational field of G. Now in class we use 10 meters per second squared, but in the real world it's right around 9.81 meters per second squared. Okay, so that's the idea of the gravitational field. When an object is in a field, the field will pull it down. This is what we call the gravitational force. Okay, so when we say potential energy is stored in an object or a field, this is the field that we're talking about. It's stored within this 9.81 meters per second squared. All right. Now, with that comes the formula for gravitational potential energy. Okay. So we use a capital U for potential energy. Not sure why it's U. The reason why I heard is because potential energy, a lot of the P variables were already taken. A subscript G for gravitational potential energy, and there are a total of 3 requirements. So you need to have an object, and that object must exist in a gravitational field, and you must have a height. So this is your first formula. Potential energy is equal to mgh. Let's talk about this h. So height is what we call a relative position, meaning that you can actually change what we call height 0, and it affects your math. So for example, let's say we have a table and we have an object on top of the table. If we call this height 0, according to the formula m times g times h, we can say that this object has gravitational potential energy of 0 joules. But if we raise the object above the height, so if we give it a positive height, we say that this is now a positive potential energy. But what if we put the object below the table or below height 0? Now we can say this has a negative gravitational potential energy. Okay, so it all depends on what you consider to be height of 0. And it is entirely up to you where you want to make your height to be 0. And I suggest the lowest point in the object's journey. That is probably the best place for your height to be 0. So for example, if we know that the object is going to start off or will eventually be on the floor, you can say, hey, why don't we make this height 0? So if the object is here, at this point, this object has a gravitational potential energy of 0 joules. And if we put it on the table, we can say, hey, on the table, it has positive gravitational potential energy. And if we put it even higher up there, we have even more gravitational potential energy because the height is so big. All right, and that describes mgh. So the other thing I want to point out is this idea called a system. So we'll get more into this system idea later, but it's important for us to be introduced to it. So a lot of the times when you see these physics problems, it'll define the system as the object Earth system. And the reason for that is if you look at the potential energy formula, you need to have the object that exists, and we have to be here on Earth, meaning that we have to consider both the object and the Earth within the context of the physics problem in order for potential energy to exist. For example, out in space, where we don't have negative 9.8 meters per second squared, we can then say there is no gravitational potential energy based off of mgh. But there is a different formula for that, and we'll cover that in a later video. All right, I'll see you later. Bye-bye.